We had 5 questions assigned for yesterday. Didn't have a chance to correct them yesterday because we worked on our labs yesterday. But we're going to check them over today. It was page 53, number 1 to 5. And I want to know if there's any issues with any of those 5 questions. Any of those ones that you'd like to go over, please. Yep, 5, okay. 4, 3. Any others, guys? We okay with those? All right. Question number 3 says, how far will a car travel if it starts from rest and experiences an acceleration of 3.75 meters per second squared forward for 5.65 seconds? Group A or Group B? Before we look at the givens, is this Group A or Group B? Yeah, it's B. It's acceleration, right? Just like your quiz was acceleration. Some people tried to use V is equal to delta D over delta T. When we were going over that quiz, we reminded you that you can't use V equals D over T whenever you have acceleration, unless you're asked for the average velocity. Okay, that's not what we were asked in the quiz. That's not what we were asked here. So it is a Group B problem. We got to use one of those Group B equations. Let's write down our givens now. We're looking for how far it travels. We're looking for the displacement. It starts at rest. We're going to say VI is equal to 0 meters per second. And we're going to say the acceleration is positive 3.75 meters per second squared, and the time is 5.65 seconds. Which of those Group B equations would you like to try first? There's no right or wrong answer. I shouldn't say there's no right answer here. There's a few right answers, lots of right answers. There's no wrong answer here. Which one do you want to try first? Fernando, which one do you want to try to find displacement there? Okay, I didn't really hear the end of it there, but I think you were going with this one, right? Yeah. Good. That's the one that I would have picked as well. But if anybody picked a different one, that's okay. Just like on the quiz, right? I picked A is equal to delta V over delta T. There's lots of different methods that people used and got it right. Same deal applies here. VI is 0 meters per second. That's good news, because 0 times 5.65 is 0. Means we're only left with 1/2 AT squared. 1/2 of 3.75 times the time of 5.65 squared. Okay, this is pretty straightforward now. The only real thing that I want to point out right now is this squared. Some people, as they're going to punch this into a calculator, will forget to square the 5.65. It seems like a small thing. It is a small thing, but it's important, and people forget to do that. So I'm not sure what that works out to be when you multiply it, but I'll assume that you can multiply those together. If you're having trouble with that, let me know. Number 4. It says, determine the acceleration of a bullet starting from rest, leaving the muzzle at 2.75 times 10 to the negative 3 seconds later, with a velocity of 460 meters per second. You're driving a car, and you got a fancy sports car. I'm driving up to a music store in Calgary the other day because my son's in grade 7 need to get these he's doing percussion in band in grade 7, had to get these I don't know what they call them, sticks or whatever you hit the things with, right? Mallets, that's what you call them, yeah. So much I know about music. Anyways, I'm driving up Blackfoot Trail, and then as I'm coming back, I go down Blackfoot and Heritage, and what do I drive past? I had no idea it was even there. There's now a Lamborghini dealership on Heritage Trail. You guys seen this? Okay, and there's no, they don't park the Lamborghinis outside, funny enough. They park them inside. I guess they don't trust the general public with their $500,000 cars just out in the hail, I guess, or whatever. Okay, these cars will go from 0 to 100 kilometers per hour in significantly less than 5 seconds. Okay, that's a high rate of acceleration. 0 to, let's say 0 to 104 seconds, although some can do it faster. Okay, 0 to 104 seconds. You're pinned against the back of that seat if you accelerate at that rate. Look at this bullet. It accelerates from 0 to 460 meters per second. That's more like, oh, I don't know, 100 and something. Sorry, no, that's something more like 1,400, 1,500 kilometers per hour in a period of 0.00275 seconds. then if you think that Lamborghini is accelerating quickly when it goes from 0 to 100 in 4 seconds, this is accelerating like almost astronomically quickly. Much, much higher rate of acceleration. I don't know what this is going to be, but I do know it's going to be a big, big number. Big number for acceleration here. What do we got? Group A or Group B? Nolan, what is this, Group A or B? Yeah, it's Group B, good. It's not constant velocity. This bullet is at rest, then it's moving. This is acceleration, so it's Group B. Let's identify our givens now. What's this? 2.75 times 10 to the negative 3. Notice, what's this correspond to?
I have no idea.
Time is 2.75 times 10 to the negative 3 seconds. What's the 460 meters per second? It's velocity final. Okay. It accelerates from rest to. That's a fairly common mistake, actually. Okay, don't laugh. Whatever, you made a mistake like that. Said 460 was the acceleration. Okay, that's a fairly common mistake. Why? Because first of all, the problem involves acceleration. Okay, so we've got that in the back of our minds already, right? Second of all, the units for this are meters per second, and acceleration is meters per second squared. It's close, right? We got to be careful to not make that mistake, but you're not the first, and you won't be the last to make it either. It is the final velocity, though. That's all we got, right? We're looking for the acceleration. Determine the acceleration, right? Anything else? If we read between the lines, Cody, what do we got? Good. VI, the initial velocity, is 0 meters per second. We're not told that exactly as clearly as we're told the other variables, but in a sense we are. It starts at rest. What do you want to do to find acceleration here? Boy, this is almost identical to our quiz question, isn't it? Let's say A is equal to delta V over delta T. VF minus VI, 460 minus 0. Remember on our quiz, it was 0 minus something? Okay, it was a negative value. Okay, this is something minus 0 because it's speeding up. What does that equal when you do the math there? 167272.72. And the units would be meters per second squared. Okay, remember I said this a few times, but remember we said gravity has an acceleration of about, you guys remember that number? Yeah, we'll say 10 for argument's sake because it's a little bit easier to do the math in our head that way. Okay, about 10, right? This is 167,000. That means this is about almost 17,000 times the acceleration of gravity, which means if you experience that acceleration, then you would feel 17,000 times heavier than you really are. If you weigh 100 pounds, which most of us in here weigh more than 100 pounds, but if you weighed 100 pounds, you would feel as if you weighed 1.7 million pounds. That's how heavy you'd feel by simply accelerating at that rate. Actually, you probably wouldn't feel like you were 1.7 million pounds because what would happen to you? Yeah, your bones would literally be crushed because they can't handle that acceleration. Your brain would be squished against your... The good news is when your brain tries to squish against your skull probably would have been crushed, so your brain actually won't squish against your cell there, or your skull there, right? You're not going to survive that, right? Obviously. The good news is normally we don't have to survive that, right? Listen, let's talk about rounding to significant figures here, okay? We're not panicking about this. If you do it wrong on a quiz, we're not taking marks off, okay? But we're starting to talk about this now. If you look at our data here, we got 3. Final answer should be 3. The only way I can do that is to say, put it in scientific notation, 1.67 times 10 to the 1, 2, 3, 4, 5. And 5, some aircraft are capable of accelerations of magnitude 42.5 meters per second squared, which is about 4 Gs, right? How many people have ever flown on an airplane? Most people have, right? I was almost your age. I've probably flown on an airplane now, I don't know, a couple hundred times. But I was almost your age before I ever flew on an airplane for the first time. I remember the very first time I was flying on an airplane by myself. My parents weren't with me. I remember taxiing out to the runway, and then you're taxiing out at a nice leisurely speed, and then you turn that corner. And what happens when you turn that corner? The giver, right? You accelerate at this crazy speed, and the first time, at least, you feel like you're really being pinned against your seat, right? Because you're accelerating so quickly to get up to a couple hundred kilometers per hour before takeoff. This question is saying that an airplane can accelerate at up to 4 Gs, 4.2, 4.3 Gs. In other words, you can, as you're being pushed against your seat, feel 4 times heavier than you really are, okay, as a result of that acceleration. The aircraft starts from rest. How long is it going to take to travel down the 2.6 kilometer runway? Let's say this is acceleration. VI, we're going to say is 0 because it starts at rest. What else we got here? Displacement is 2.6 kilometers. Probably not a bad idea, though. Look, kilometers. Draw attention to that in red pen. 2.6 kilometers is 2,600 meters. We want to know how long it's going to take. Is this group A or group B? It's B. Clearly it's group B. Most of what we do right now is group B. Although you remember the other day, we did a problem where there was 3 stages. There was a group B, a group A, and a group B. So it can happen that we could still have group A. You just got to be aware of that. What do you want to try? Looking for T here. Maybe this one? Maybe this one here? Solving for A. No, sorry, solving for T. Oh, good news though. If VI wasn't 0, this would be impossible to solve for T with what you know mathematically. But the good news is VI is 0. That means that entire term disappears. I'm left with an equation that's quite a bit simpler now. D is equal to 1/2 of A T squared. Okay, if I want to solve for T, what do I have to get rid of first? Yep, Mackenzie? 1/2 in the A. And how am I going to do that? Yeah, it's multiplied by T, so we're going to divide it. It's going to be D divided by 1/2 of A equals T squared. And then what do you got to do? What do you got to do? Good. Square root that. So it's going to be P is equal to the square root of D over 1/2 A. Does anybody have an equation that looks like this? Did anybody write it down that way? What did I do here? What did Mackenzie tell me to do here? Divide by 1/2 A, right? Is that right? Absolutely. What else could we have done? Divide by A and multiply by 2. Okay, dividing by 1/2, multiplying by 2 is the same thing. Okay. This is a little bit neater, but it's no better. Yeah, let's see what we can get here. Displacement is 2,600. 1/2 of 42.5. And then we got to square root that. What does that work out to be? 11.05 seconds, which should round to how many digits? 1, 2, 3, 1, 2. Final answer should be good, 2 digits. So we could say that's technically just 11 seconds. Sorry? We square rooted that already. Yeah, that's including the square root. So 2,600 divided by this is something like 121, and then you're going to square root that.